Space. You can get a good sense of it here in the Owens Valley. While it's beautiful, we're not just here for the awesome views of mountains. The valley floor actually provides a great view of outer space as well.
Why? Well, we have the White Mountains over here, back here are the Inyo Mountains, and all across here are the Sierras. And that's important because in 250 miles in each direction, we've got San Francisco, Las Vegas, and Los Angeles. And each of those cities makes a lot of noise.
It's not the audio noise that we want to shield ourselves from, but the radio noise, from an increasing cacophony of electronic communications devices upon which we all rely on more and more to send information at radio frequencies. While optical observatories need to be as far from visible light pollution as possible, high up on mountaintops to get above the turbulent atmosphere, radio observatories just need to get away from human-made interference, or at least be able to block it, and the mountains happily fill that role.
Radio astronomers can actually observe during the daytime. That's because the sun emits very little light in radio wavelengths. In fact, that's probably one reason why we've evolved to see the color of light that we can see. The sun emits more yellow and green light than anything else. The most of yellow and green, then orange and blue, then red and purple, and then even less of infrared and ultraviolet, which we can't even see at all.
This concept of how much light something emits at each wavelength is called a spectrum, and the entire electromagnetic spectrum of light is actually much larger than the little sliver of the spectrum that we can see with our eyes.
Imagine if the sun emitted mostly infrared wavelengths. Perhaps we would have infrared vision.
But with the sun emitting more yellow and green light than anything else, that's at least one reason why we think plants are green, so they can soak up as much of the sun's energy as efficiently as possible.
Right here, we're not too far from the desert of Death Valley, so there's not much green around here. Let's pretend, just for a moment, that for one reason or another, we evolved to see in radio waves. Microwaves, to be exact. 1 to 2 centimeters. Then, day or night, the sky would always be an even glow.
This is because the sky is awash with the afterglow of the Big Bang. Nearly the same in all directions, this glow peaks in the microwave part of the electromagnetic spectrum. So it is no surprise then that the astrophysicists and cosmologists have given it the name of cosmic microwave background, or CMB.
Scientists and engineers at Caltech's Owens Valley Radio Observatory are studying this afterglow of the Big Bang and trying to learn more about our universe from it. Let's go meet someone now who's building an instrument to study this in a new way.
Becoming a radio astronomer starts with curiosity. You've got to be curious about how things work and taking things apart to figure out how they go together. The thought that since the birth of the universe, these radio waves have been traveling, in the time that galaxies have spun up and formed, and stars have been born and died, and Earth formed and cooled and life started, these radio waves have been traveling non-stop. Being good at math and science is almost all about working hard. We all are challenged by it. We all find it difficult, and you get better at it by working hard at it. It's not true that you have to have a talent or a skill for math and science. That's not true at all. You have to be willing to work hard at it and try and understand. And that, there's a saying, genius is 90% perspiration and only 10% inspiration. I think that's understatement. Genius is 95% or 99% perspiration. So work hard, and the goal is worth it. This, Sarah, is the heart of a radio receiver. It's called the cryostat. That sound you hear in the background, pulsing in and out, that is the sound of high pressure helium gas expanding and contracting inside that metal can, and that cools down the inside of that can to near absolute zero.
The cosmic microwave background didn't always peak at microwaves, or any of the radio wavelengths for that matter. Since the Big Bang, the universe has been cooling largely due to the expansion of space itself.
In the very beginning, the universe was condensed down into an extremely small point, much, much smaller than this little rock. And it was extremely hot.
Then we think the universe went through a period of dramatic inflation, when everything, including space itself, expanded very quickly. Billions of years later, long after the first stars and galaxies formed, something else started to make the universe expand at an ever-accelerating rate. This mystery is called dark energy, and it will have to be the subject of another episode of Beyond. But until then, just remember that it is neither necessarily dark nor energy, but rather the explanation for whatever is making the universe expand at an ever-accelerating rate. This is something that has been haunting astrophysicists and cosmologists for quite a few years now. One of the many reasons why the expansion of the universe is important is because it has in turn cooled down the universe. Just as fire changes color when it burns hotter, the light left over from the Big Bang has changed color as the universe has become cooler. Right after the Big Bang, had there been any eyes around to see, there would have been some visible light, but mostly infrared. As the universe expanded, so did those light waves from the afterglow of the Big Bang. And now they are stretched all the way out to microwave and radio wavelengths. As the universe continues to expand, the Big Bang afterglow will continue to get cooler still. We must not take our ever-changing skies for granted. Instead, we must continue to push the boundaries of technology and instrumentation to observe all varieties of what our universe is showing us. Learning more about math, physics, and astronomy can open up the skies to you in new and exciting ways. After all, in learning more about how the universe began, we are in turn learning more about where we came from, and ultimately, how we began. We are not just children of the universe, but as much a part of it as the mighty planets or the gracefully spiraling galaxies.
We're glad you joined us here on Beyond. Join us again for another astrophysical adventure, but until then, keep your eyes on the skies and beyond.